And you have a quadratic and a linear factor. So this was like one of the examples we did in class yesterday. So the quadratic factor has an ax plus b, and then the linear factor just gets the c on top. So the first step after you have it factored, you have your setup step here, we need to multiply by that least common denominator, which of course is just whatever the left denominator says. And then, Darby, can you give me the expression that you have after you multiplied by the least common denominator?
So I did ax squared minus ax plus bx minus b, and then plus cx squared plus c.
Good. So that would be taking the numerator, multiplying it by the missing part from the least common denominator. Organizing all of your like terms, we have an ax squared and a cx squared. And then we have a negative ax and a bx. Again, keep that negative sign with the a. And then finally, a negative b and a c. So Cole, after we have these grouped together, what do you do next?
You would have a plus c is equal to 1, and then negative a plus b is equal to 2.
And then the last one, what's that equal to?
0.
Yeah, nice. 0. Good. So Gaussian elimination works pretty nicely. If I want to just pair the first two together, I see I have a positive a and a negative a. And there are multiple ways to work through this. Totally up to you. But if I add them together, the a's cancel, and we end up with b plus c equals 3. So pairing equation 1 and equation 2 together, having a positive a and a negative a works out pretty nice. And then if we pull the third equation that Cole gave us, negative b plus c, we end up with 2c equals 3. So c is a horrible fraction of 3/2, but not so horrible. I actually think number 2's fractions, having that 1/8 was a little worse. So we have c as being 3/2. So once you figure out c, go back in and find a, and I would go back in and find c, or I'm sorry, b. So Peter, what did you get for a and b?
For A, I got negative 1/2, and for B, I got 3/2.
Yeah, nice. So 3 variables, 3 fractions. So the last step, we want to then finish our partial fraction, and it says ax plus b. So a is negative 1/2, b is 3/2. That goes over x squared plus 1. C is 3/2, and that's with x minus 1. So if you look at the numerators, each one of these numerators contain a fraction. And generally, it's not simplified or proper to leave a fraction in the numerator of a fraction. That's called a complex fraction. So the denominator of that 3/2, or the denominator of the 1/2 and the 3/2, that really can be moved to the denominator of my factors, the x squared plus 1 and the x minus 1. So with the first fraction, I would factor out a 1/2, or you could factor out a negative 1/2, completely up to you. But if you factor out a 1/2, that leaves then negative x plus 3. And then we have x squared plus 1. They both have a 1/2 in common, so I could take out that 1/2. And then the denominator literally moves to the denominator. So if I have a 1/2 on top, that's the same thing as having that 2 move to the denominator of the fraction. And then the 3 having the 2 in the denominator. Questions?
I have one. So
Yeah.
I just took out the 1/2 out of the entire equation and put that in the front. Would that still work?
That is 100% would be fine as well. So you have 1/2 and then you have the whole thing being multiplied, and that would be perfect as well. Yes.
Okay.
Totally
Okay, thank
fine.
you.
Yep. But don't leave the fraction in the numerator. So try and get that, like, the whatever you're dividing by in that fraction really goes in the actual denominator of our fraction. So it just becomes part of that factor. Questions? All right, so as I said, we're going to do this wonderful improper fraction. So remember, the process of decomposing is going to be the same. So the decomposing part, breaking up our fractions, like most of this part is going to be the same. We just have to do one step to start this problem because it is an improper fraction before we can do any kind of decomposing with the fraction. So this page here, I don't even know what page it is. I think it's page 21, maybe 22, maybe it's 22. But looking at these fractions, the degree of the numerator is bigger than the degree of the denominator. And when that happens, it's considered an improper fraction, just like with numbers. So if the number on top is bigger than the number on the bottom, 7/5 is considered an improper fraction as well. Algebraically, when the fraction is improper, we cannot do anything with that fraction until it becomes a proper fraction. So I can't decompose it into its separate fractions until it's a proper fraction. The method we use to make it a proper fraction is to divide. So thinking numerically, if I have 7/5, I divide 5 into 7 and it goes one time, and then my remaining would be 2/5. That's how we would make a numerical fraction proper, or in this case, it would be a mixed number. But you're saying how many times does 5 go into 7? It goes one time with a remainder of 2 out of 5. Well, we're going to do that same thing, but we're going to do that algebraically. We're going to take that denominator, that x squared plus x minus 2, and we're going to divide it into the numerator. And with division of polynomials, we have to do long division. So we're taking the denominator and we're going to divide it into the numerator. Actually, I'm not going to copy that because it's missing a term. So our numerator has an x cubed, missing an x squared. So I'm going to plug that in. That's why I didn't end up copying it. And then there's a negative x and a plus 3. Way back in chapter 2, we talked about polynomial long division. Does anybody remember how to do polynomial long division? Peter, what do you think?
Wouldn't you take x squared and c, like what you have to multiply it by to get x cubed.
Yeah, that's exactly right. So only looking at x squared, only looking at x cubed. One term at a time. So Peter, how many times or what would you multiply x squared by to make it x cubed?
You would multiply it by x.
Right. And then what do you do with that x after we place it on the top of our fraction or quotient symbol?
You would multiply it by x squared plus x minus 2 and then subtract it from the x cubed plus 0 x squared minus x.
Nice job. So x squared times x makes x cubed. And then you take the x on the top and you multiply it by each one of those terms. So x cubed plus x squared minus 2x. So x needs to multiply by the entire quantity, x squared plus x minus 2. And then he said you subtract. And remember, when you're subtracting all of it. So that means I'm subtracting the x squared and we're adding the 2x. So we end up with negative x squared plus x, and then we bring down the 3. So Peter, you have an x squared. We need to make it a negative x squared. What would you multiply it by?
-1.
A -1. So again, take all of the x squared plus x minus 2 and multiply it by -1. So negative x squared, a negative x, a positive 2. You're subtracting that whole quantity. So this is a plus, this is a plus, and that becomes a minus. So Peter, what are you left with after you divide?
You're left with a 1.
Anything else besides a 1?
Oh, it'd be a 2x with it.
Yeah. So this is our remainder. This part up here, that's our quotient. That x minus 1 is the part that was pulled out from our original numerator. So our new fraction, after you have division, becomes x minus 1, and that quantity was pulled out or technically factored out using long division. The new fraction is your remainder over what we divided with, our divisor, x squared plus x minus 2. Just like if I had 7 over 5, I pulled out a 1 and I'm left with 2 out of 5. It's the same thing. So I pulled out the 1, I'm left with 2 out of 5. Well, we pulled out x minus 1, oops. We're left with the 2x plus 1 out of my original denominator, x squared plus x minus 2. Questions? So when we go to do our partial fraction, we are now using our new fraction, which is now proper. So our numerator is 2x plus 1 because we pulled out the x minus 1. The denominator doesn't change. And actually, before I write it, let's just factor it. So it looks like we have a positive 2 and a negative 1. So it's now proper because the power on the top is less than the power on the bottom. And now we can do the partial fractions. So Kaden, what would our two partial fractions become?
A over x plus 2, and then b over x minus 1.
Yeah. And then Kaden, when you multiply by that least common denominator, what do you have?
We have 2x plus 1 equals a times x minus 1 plus b times x plus 2.
Nice. So this is going to be pretty nice after you do the long division, because you see we only have a and b to worry about. There aren't any x squared terms. So ax minus a, bx minus 2b, and then go through the process. So pull your terms together, keeping both of those negative signs with those constants. That negative a and that should be a plus 2b, it shouldn't be a minus. That's not Caden's fault, that's mine. So Hannah, what are our two equations that we're going to be solving?
A plus b equals 2, and then negative a plus 2b equals 1.
Good. So Hannah, if you solve those two, what do you get for b?
Sorry, I was muted.
No, it's
You get-
okay.
You get 3b equals 3, and then b equals 1.
Perfect. And if b equals 1, Hannah, that means a is equal to?
1.
Yeah, what a boring fraction. A and b are both 1. Questions? All right, so when you go to write your answer, remember that the original fraction was x cubed minus x plus 3. And we pulled out or factored out using long division x minus 1. That x minus 1 still needs to be a part of our final answer, not just the partial fractions, but the quantity that we factored out by using long division. So when I write the answer, we had our original fraction, and it is now equal to what we factored out, which was x minus 1. And then a is 1 over the factor x plus 2. B is 1 over the factor x minus 1. So those three quantities create our original fraction of x cubed minus x plus 3 over x squared plus x minus 1. But again, please make sure you're including that x minus 1 in the answer. Because if I just had the partial fractions, it wouldn't get me my original fraction. It would give me the leftover fraction, but not my starting problem. Does anyone have questions? So a little bit of review with long division coming back into play, creating a proper fraction. It's your remainder that makes the proper fraction. So the answer that you get on the top is the part you factor out. The remainder is the portion that then creates your new fraction. Any questions? So that is all we have. I told you yesterday it would be a short day. One problem from the homework is an improper fraction and it's number 67. The other 5 are not, and they're really just review problems for us to finalize this process, and hopefully everybody is feeling a little more comfortable with the process. The answers are provided because there are a lot of even problems, and of course they're not in the back of the book. So I do have the answers provided for you. Tomorrow in class, we'll just kind of, as I said, wrap up, summarize, review, get any questions answered for the test on Friday. So you are free to go. If you want to remain on and ask any questions, please do so. I will still be here. I'm not shutting down the Zoom.